In this example, we're going to deal with a couple of non-standard bases in R3. So the two bases that we're going to be dealing with will be basis B, which is comprised of the vectors 1, 1, 1, 1, negative 1, 1, and 0, 0, 1. Basis B prime will be comprised of the three vectors 2, 2, 0, 0, 1, 1, and 1, 0, 1. We're going to find the following. The transition matrix that'll take us from B to B prime, the transition matrix that'll take us from B prime to B, and then given a coordinate matrix relative to the basis B prime, we're going to find the corresponding coordinate matrix relative to the basis B. So, as far as part A is concerned, we will be creating a 3x6 augmented matrix, and the basis that we are transitioning to goes on the left, and the basis that we're transitioning from goes on the right. Now the basis that we are transitioning to, we're going to B prime in part A. We are coming from B. So loading into this matrix, the first three columns are going to be the vectors of B prime. So we'll see a 2, 2, 0 for the first vector, then 0, 1, 1 for the second vector, and 1, 0, 1 for the third vector. Transitioning from B, we'll load the three vectors of B in, same as what we just did. So 1, 1, 1 for the fourth column, 1, negative 1, 1 for the fifth column, and 0, 0, 1 for the sixth column. We're going to take this down to reduced row echelon form, and if you think we're doing that by hand, you are crazy. We're going to grab our graphing calculator. We're going to enter the matrix menu. We will edit ourselves a 3x6 matrix, and we'll go ahead and load in one row at a time. So first row is 2, 0, 1, 1, 1, 0. Second row, 2, 1, 0, 1, negative 1, 0. Third row, 0, 1, 1, 1, 1, 1. Then we'll take a look at our matrix, make sure that everything got inputted correctly. 2, 2, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1, 1, negative 1, 1, 0, 0, 1. Okay, looks good. Re-entering the matrix menu, we will ask for reduced row echelon form of the matrix A, close the parentheses, and then math enter enter to convert it to a fraction if necessary. And it looks like in this example, it was quite necessary for us to do so. So for the left of the augment, I'm simply going to use I to represent this. And to the right of the augment, we have a lot of fractions. That is 1 quarter, negative 1 quarter, negative 1 quarter, 1 half, negative 1 half, 1 half, 1 half, 3 halves, and 1 half. Now for the sake of space on this page, we'll just say that this 3x3 matrix that we wind up with here is referred to as the transition matrix, and we will refer to this for the time being as P inverse. That way when we find the transition matrix in the other direction, that will just be P. Now speaking of, for part B of this problem, that's exactly what we're going to be doing. Now one thing that you could do is simply load this matrix into your calculator and then find its inverse, and that would transition us in the opposite direction, from B prime to B. However, since I want to try to be as thorough as possible, we'll do the same thing as what we did for part A. 2 goes on the left, from goes on the right. This time we are going to B from B prime, as was prescribed right here. So 2b, we'll once again load these vectors. This was 1, 1, 1, 1, negative 1, 1, and 0, 0, 1, same as what we had for the augment for the previous problem. And then coming from 2, 2, 1, or excuse me, 2, 2, 0, 0, 1, 1, 1, 0, 1. Once again, for this 3x6 matrix, we'll be taking this down to reduced row echelon form. So once again, in our matrix, we're going to edit ourselves a 3x6, and we'll just load this one row at a time. 1, 1, 0, 2, 0, 1 for the first row. Hi, BB. 1, negative 1, 0, 2, 1, 0 for the second row, 1, 1, 1, 0, 1, 1 for the third row. Then we'll just take a quick look at the matrix, make sure that everything got loaded in correctly. 1, 1, 1, 1, negative 1, 1, 0, 0, 1, 2, 2, 0, 0, 1, 1, 1, 0, 1. Looks like everything worked out just fine. Next up, we're going to ask for a reduced row echelon form of matrix A. Once again, pressing Math Enter Enter to see if we wind up getting some fractions. And once again, we are seeing some fractions in here. Once again, to save space here, we'll say that the left of the augment is simply the 3 by 3 identity matrix. And to the right of the augment, I'm seeing 2, 1 half, 1 half, 0, negative 1 half, 1 half, negative 2, 1, and 0. This matrix will be known as transition matrix P. Now, normally, another part of this problem would be to verify that these two things are inverses. However, to do so with a calculator is relatively straightforward. We could load both of these into the calculator and then simply multiply them to verify that we get the identity matrix, or load one of the matrices and then ask for the inverse and verify that we get the other one. Now, as far as part C is concerned, we have been told that the coordinate matrix of x relative to basis B prime is equal to the coordinate matrix 2, 3, 1. This means that for part C, we are going to be transitioning from B prime to B. From B prime to B means that we should be using our result from part B, the transition matrix from B prime to B. So we're going to be using this matrix as our transition matrix. So we'll take our matrix P, which is 2, 1 half, 1 half, 0, negative 1 half, 1 half, negative 2, 1, 0. We are going to multiply that by 2, 3, 1. I think I can probably handle this by hand, but we'll see what happens. 2 times 2 is 4, 3 halves, 1 half, 3 halves plus 1 half is 2, plus an additional 4 will be 6. 2 times 0, negative 3 halves, plus 1 half, that'll be negative 1. Negative 4, plus 3, plus 0, that'll be negative 1. This should be the coordinate matrix of x relative to basis B. Now here is how we check our answer. So what we're saying is that for basis B prime with this 2, 3, 1, we're saying we have 2 of these, 3 of these, and 1 of these. For basis B, what we're saying with 6, negative 1, negative 1 is that we have 6 of these, minus 1 of these, minus 1 of these. So what I'm going to do is attempt to set that up. So we are going to show that 2, 3, 1 relative to basis B prime is equal to 6, negative 1, negative 1 relative to basis B. So setting this up, this would be 2 times our elements of B prime. Let's bring those back onto the camera so that we can copy them down. So the elements of B prime are 2, 2, 0, plus 3 times 0, 1, 1, plus 1 times the third one, 1, 0, 1. Allegedly, this is going to be equal to 6 of the first vector in B, minus 1 of the second vector in B, minus 1 of the third vector in B. We are going to attempt to show that these two things are equal. And we'll do it one component at a time. So for the first component on the left-hand side, 2 times 2 is 4, 3 times 0 is 0, plus 1, 4 plus 1 is 5. For the second component, 2 times 2 is 4, plus 3 plus 0. 4 plus 3 plus 0 is 7. For the third component, 2 times 0, 3 times 1 and 1 gives us 4. And we'll do the same thing on the right-hand side of the equation for the first component. 6 times 1 minus 0. That'll be 5. For the second component, 6 times 1 minus -1 minus 0. And finally, 6 times 1 minus 1 minus 1 is 4. That verifies that our answer is correct. So 3, 2, 1 relative to the basis b prime is the same as 6, -1, -1 relative to the basis